grab a seat. We'll just start in 1 minute. And here's the QR code for the link. Feel free to scan it and sign in for this meetup. Thanks. We're also gonna have our volunteer photographer today using the camera to recording this meetup. Feel free to let us know if you do, considering a private issue, you don't wanna get input. Thanks. Okay, let's start. So AI Camp, we're hosting virtual and in-person meetups for all over the world, mainly in US and UK, China, Australia, including most major cities in those countries. And for the audience, we're targeting to developers focused on the machine learning and AI development. We're also looking for sponsors, speakers, and if you have the passion about AI and machine learning technology, please feel free to reach out to us. So we got AI Camp community member Gail, our fan back there, raise your hand. So I'm Hannah, feel free to talk to us. Here's the QR code for our Discord. If you're looking for co-founders, looking for jobs, looking for higher talent developers, feel free to join in. We also have virtual meetups. You can find those information on aicamp.ai. So very big thank you to our sponsors, Neo4j, Natural Velocity, and Hugo, our old friend. Okay, these are our speakers. We have speakers from Neo4j, Muddassir, and Angelo. We also have Hugo. Where are you? Okay, and giving our second speech. Before we start our talk, we'll welcome John, who's the CEO of the Natural Velocity, to give a brief picture. Thanks.
Cool. Thanks, Hannah. I'll just quickly plug in. So apologies to those people who've seen this a couple of times. I know a few of you look familiar from other meetup groups we hold here. So any second, this is going to come up for me. There we go. So just to tell you quickly a little bit about Natural Velocity. So essentially, we are an ecosystem business. And what we're out to do, this is quite an ambitious goal, is to humanize and accelerate the adoption of ethical AI in cyber. The reason why we want to accelerate is because AI is set to contribute $315 billion to the Australian economy by 2030. So clearly, if we can get there quicker than 2030, that's a good thing. And so the way we do that is actually through an ecosystem. And this will become quite relevant why we took you into the co-working space first. So at the bottom of the ecosystem is a series of layers, and there's a bit to this. Apologies if there's a bit complex. Is the Natural Velocity Innovation Centre. So this is a co-working space. Obviously, you know where we are. We're in Docklands. Oopsie, sorry. Need my mouse. We're in Docklands. That sign's not here yet, but we can get about 1,000 people in here. So many of you may be aware that the wheel got built. All the retailers came in, all the people came in. The wheel then broke on a hot summer's day. It then got rebuilt, but that took about 2 years. The company then went bust that built it. So then we had COVID. So during this time, lots of retailers who came in then started leaving. So it's had a bit of a reputation, unfortunately, as being a bit quiet, but I can assure you it is coming back to life, and we're certainly big contributors to that. So it makes it a really, really good space for co-working. So we're really close to, as you can see, the city. And the first thing I'll tell you about this, so we're a very different co-working space. In fact, we don't like being dropped in the co-working bucket, because first thing about the space is we run the network here. So if you're a startup and you're interested in maybe deploying your tech, we can probably facilitate that. Say you want to go into the ice skating rink as an example, good chance we can help facilitate those sorts of things for you. The other thing is we're right next door to, many of you possibly don't know, that just a few hundred meters that way is the largest LED screen in the Southern Hemisphere as part of Docklands Studios. So that was Noodles just there. She's 6 foot. She's not sure. Yes. So Liam Nielsen was in here just recently shooting a movie. So we want to turn this place into Australia's leading AI and cyber hub, and it's an awesome place to do that. The other thing about it is we have heaps of entertainment here. So if you want to go and shoot zombies, we've got VR labs down here. We can go and shoot zombies. Perhaps you want to do go-karting, or perhaps you want to do dodgems or 10-pin bowling. There's a Star Wars exhibition here. We've got Dreamscape. There's a flight simulator. There's just lots to do here while you're not building AI amazing applications. The wheel is coming back to life a little bit later in the year. It's already been tested. And happy to say that if you've started with us, then you can book a pod on the wheel for customer meetings. If the customer doesn't sign your contract, a hatch at the bottom of the wheel opens and the customer falls to the ground. Clearly, I'm just joking about that part. That's a good dad joke for you. So we're also really close to the airport. So all the freeway terminations, so the new Westgate Tunnel terminates here, and a lot of the freeway terminations are right at the back door. And we have 2,200 car parks here for just $7 a day if you're a resident. So this slide's really important. It looks very basic, but essentially we're hearing from a lot of AI people saying AI compute's really expensive. It's killing me. I'm getting bill shock off AWS and Azure, because particularly AI payloads tend to be they can fluctuate a bit. And so we give you the ability, we have a marketplace, which we're going to go to shortly, an AI marketplace, so you can procure servers from us. And we have computer rooms here. So the key thing about this slide is we're a tech company running a co-working space, not a co-working space simply trying to flog your desks. It's a really, really big difference. So we're here to support particularly AI people, like such as yourself, and we even have Bueti's picture theatres here. Imagine going along, learning all about AI in a cinema like this, and here's your choc top and your popcorn. How good is that? The last thing on the co-working spaces, this area you're in is going to be redeveloped shortly into an amazing training centre and experience centre, because customers are confused. They don't know where to start with AI. It's really confusing for them and who to trust. So they can come into the training centre, which is going to be around about here, experience centre over here, learn all about AI and robotics as an example in the centre. Oops. Lastly, we have 3 desk options. We have virtual desks. You can't invite a customer around to your lounge, so you can say you work with us, but you don't really, but you can still come and use meeting rooms. We have silver level, which is the area you're in, and then platinum is coming later in the year, where you'll need it'll have biometric access and all those sorts of things for the startups that really want the high tech. Now, I've talked a lot about startups here, but this is really equally at home for customers, corporates who want to come in and be close to the AI action, scale-ups as well, so not just startups. So the next part of differentiation for us is startups come in, they join us, they then start building tech. They start building apps, they start building services, support services, and all this capability then flows to a marketplace. So this marketplace is about to launch with a whole heap of product in it. And if you're building AI solutions, we would love to have your solution in the marketplace. So the only co-working space, and we don't really want to be known for that, but let's just call it co-working for the moment. Only co-working space where your tech can actually scale, go into a marketplace, and now we can help you scale globally. No other co-working space globally does this. 2 minutes. So in the marketplace, we also have Dell, Supermicro, and NVIDIA, funny enough. We also have over the top of that value-added services. So we have an agentic AI ecosystem that we're building to really lift up all the AI applications. We have deployment blueprints. We're really out to solve the consumption problem for customers, making it super easy for them to consume AI. Lastly, customers and channel at the top. And so the top part of the ecosystem is what we call the delivery network. How do we get the right AI apps to the right people at the right time with the right outcome, with the right security and governance? That's essentially what we're all about here. So it means amazing incremental value creation up and down the stack. It also means that we can commercialize any AI applications globally. And we're also launching an accelerator shortly. So any of you is interested in specifically a tech accelerator, we're doing that. and we don't take equity in your business for ourselves. So this is an idea of what the sort of marketplace looks like. And we also then have customer requirements flowing down to us. So if you're in the co-working space, we can potentially introduce you to customers. So there's lead gen for you, which you won't get anywhere else. We've got firewalls and guardrails to wrap around the ecosystem as well. And then the other big thing we're very focused on is skills. So according to Australian Computer Society, Australia's going to need 129,000 additional AI people by 2030. So you guys are clearly in a good space. But the universities, unfortunately, are not going to be able to keep up, simply because their syllabus is changeover is too slow. So we've got workplace industry learning programs. We've got an accelerator program coming through here as well. We've got heaps of room to bring students through. And this is our way of trying to close that gap, which we need to do, going back to that goal of bringing forward all that goodness for Australia. So our belief is if you put in place an ecosystem with the right people, processes, and technology, we're a very strong values company underpinned by putting back, making the world a better place through technology. And if you put all these things together, then essentially it's only natural that you're going to get velocitization of AI. So thank you very much, everyone. I enjoyed the night, and see you back up outside. Thanks. By the way, if you're interested in, please connect with us on LinkedIn. Here's a QR code if you'd like to do that, and follow us. We've got lots of events coming up that you may be interested in.
Oh, thank you so much, John. We'll have our first speaker introduce themselves.
Like this one?
Would you like to share your screen so people may talk?
Is it better like this? Or
I'll just talk while we set up.
Yep.
Thank you so much for allowing us to share at today's event. I also want to thank the National Velocity team for sharing this space with us. And yeah, AI is such an exciting topic, right? And I really hope, one day we're in one of those big cinemas with a massive audience discussing AI. It's super exciting. So this is a talk about supercharging LLMs with knowledge graphs and GraphRAG. And I'm Angelo. I work in the, I'm going to stop doing that. I'm going to stand, I'm going to pick a spot. I'm going to stand on this side. Thank you. Oh, you could just guess what I'm talking about, right? And see who's awake. I'm Angelo. I work in the Neo4j professional services team. Been with Neo4j for 5 years now. I work at Muddassir, Zaidi, who's a co-speaker with me today. And we have connections. This talk is about graphs. I'm going to use a little bit of a graph to explain who we are. So besides working at Neo4j, I enjoy cricket. I watch cricket. He coaches cricket, so a bit more advanced than me just watching it. But we both love graph, right? We're going to share a little bit about graph in this talk today. And hopefully we share something that's useful for you guys in your exploration of AI projects and the various tools that you have to accelerate your ambitions. So while I'm talking, right, during my bit, please feel free to play with our tool, right? So if you've got time, feel free to take a quick photo and you can create a free instance of Neo4j Aura. You can use those login credentials to play with a labs project, which we're going to demonstrate today. So click the scan me code there, create your Neo4j Aura, get your credentials, set yourself up on the LLM builder. And while we're talking, feel free to play, right? You can point it at a website and start building your own graph using an LLM. So don't just take our word for it. You can play with it yourself as we talk. And hopefully we can talk about it later. So this is a talk about knowledge graphs and how they supercharge LLMs, right? And to start that conversation, it's important to see the baseline for the team, right? For the audience here in terms of understanding of graph. So question for the audience, who's heard of graph? Generally, everyone has, right? When we think of graph, we think of the pictorial representation of data, right? And really a graph in this form is representing relationships, right? It's looking at the relationship between things and representing that in this graphic. When we talk about graphs today, we're talking specifically around graph theory, right? And its application in computer science. And so when we represent graph, you're going to see pictures like this. But again, it's all about the relationship between entities in your data set. And when you represent data, your data in a graph, right, you realize that anything can be represented as a graph, right? So if you caught the metro here today and you think about what the metro system is, it's a series of stations connected by rail line to other stations. It has information about the length of those tracks, the timing in which trains are going to leave the station. All that information can be represented in the graph. Graph can also be represented in nature, right? So we can represent molecules that make up the fundamentals of chemistry, represent that in a graph. We can even take something as mundane as a chair and look at all the components that make up a chair and represent that in a graph. So when you start to play with graph, you start to realize that graphs are everywhere. Graphs can be used to solve theoretical problems, right? So there's a math element to this. An example, it's been around for centuries, but an example here, there's 7 bridges of Königsberg problem. The question was proposed, is there any route in the city where you can traverse this bridge only once, right? The bridges that exist in the city, can you traverse it only once? And if you look at it subjectively, yes, you can see that you can't, right? If you go through the middle, you're gonna cross a bridge more than once. And you can represent that mathematically using a graph. But we can also represent practical problems with graph, right? And a lot of what we're going to talk to you today is those practical problems. In this example, we're looking at a fraud use case, right? We're looking at the relationship between people within our graph, right? Looking at the types of things that they're connected to and representing that. And so part of this talk is about Neo4j and Neo4j's labeled property graph. And since I'm baselining everyone's understanding of graph, I'm going to go through some of the key 4 components of a graph. The first one is the fact that it's made up of nodes. It's made up of things. Mathematically, we describe that as the vertices, right? And these things are connected to other things, and those are relationships or edges in terms of the mathematical description. And so these edges, these relationships have direction, they have types, and we can further enrich those with labels, right? So we can define our nodes with roles. We can have more than one label that represent our nodes. And we can further enrich that with properties. These properties can exist per this graph, per this image. We can have nodes with places, cities. We can have relationships and properties such as where someone lives. And so bringing that back to for those of you that are new to Graph Database, if you're working with relational databases, you can think of your rows as nodes. You can think of your joins as relationships. You can think of your table names as labels and your columns as properties. So why is this all important? What am I leading to? Well, your data can be enriched when you understand the relationships within your data set. Those relationships give you context, right? And that's very important when we talk about knowledge graphs. When we build multiple graphs together, we are looking to connect that information. And lastly, an example of a knowledge graph is this retail example where we build a knowledge graph connecting together lots of information based on various domains within an organization, and we can represent that in this example. Okay. So at the heart of the Neo4j graph data platform, we have the graph database. We have a graph data science library capability. We have various development tools and frameworks that you use with the Neo4j platform. And we have various visualization tool. Sorry, I've got a really sore throat that's throwing me off.
So I don't need it. So just to pick up from where on the left, in terms of Neo4j graph capability, there are many components available for you that you can use. So obviously, one is the native database, graph database that we have been talking about, label property graph, which has all these components that Angelo showed you. Then we have Graph Data Science Library, which kind of builds on those knowledge graphs and gives you analytical algorithms that you can run on those knowledge graphs to get an outcome. Then we have other suite of development tools and frameworks. Some of them we'll demo today, but obviously in a short time we cannot demo everything else. So we'll give you links along the way, and then you can click on those links in your own time, play with that, and see what are things that are available for you. Then we have other graph visualization tools. Some of them are owned by Neo4j, but we work with partners as well. There's a partner ecosystem that kind of use a graph database and build their own visualization tools based on the domain that they are working in. And some are natively available from Neo4j. And then there's obviously graph query language support. So as I mentioned, it can be on-prem as well as on cloud. You have all the options. It's a free version is also available for the developers who can get into it, and you can get that on the cloud as well, which gives you some credits to play around with. So moving on. So if you want to know more about graphs, we have a Graph Academy. You can scan this link and go to Graph Academy, which has free classes. It gives you the access to all the instances, and you can play around and get to know more about how graphs work. So just another survey. Obviously, who has not heard of LLMs before? Everybody has heard of LLM. That's good. And who has deployed LLMs for a business use case? Good. Few of you are working with LLM. So those of you who have used LLM for a business use case will understand what are the shortcomings of LLMs when you deploy in a business use case. Generally, LLMs don't have a detailed domain knowledge. They have limited domain knowledge or generalized domain knowledge based on the domain data available around that domain. Very difficult to explain the outcomes of LLM, and it's very hard to understand what was the context from which the LLM fetched this answer, because that kind of aids in explainability. So what to do about that? You basically combine knowledge graphs with LLM to give it a business context. And that's what we're going to talk about today. So if you consider LLM as the right side of the brain, which has reasoning, creativity, language support, knowledge graphs are the left side of the brain, which kind of gives you the knowledge, the context, and enrich that knowledge, which LLMs already hold in terms of creativity. They work better together, and we're going to discuss that in detail. So to build on that concept, we introduced a new concept called GraphRAG. Have you guys worked with RAG before, RAG implementation? Raise the hand. Has anybody experimented with GraphRAGs before? Okay, so good. Some people have an understanding of that. So what is a GraphRAG? Essentially, just to explain GraphRAG, RAG is a retrieval which is augmented for generation, right? But in a GraphRAG, on the retrieval step, you have a knowledge graph involved, right? Generally, it's not just a knowledge graph. There can be other things like vector DBs and all those sorts of things. But if there is a knowledge graph in between that ecosystem, it's called a GraphRAG. So just to put it simply, we'll take a context of simple customer support chatbot, right? Your company is manufacturing Wi-Fi devices and providing support on that, right? So you will have textual documents that document all the features of that Wi-Fi router, what are the typical troubleshooting exercises, and all those documents are stored somewhere, right? A user comes in and he asks a question, my router is showing these lights, what's the problem with it? How can I solve it, right? So how do we solve that? Basically, we take that question and we kind of generate an embedding vector for that question, right? that embedding vector is returned to the user, and that embedding vector and to the application, and that embedding vector is passed in to your knowledge graph with vector support, right? So in terms of that context, the embedding vector will give you which articles kind of match closely with this answer. If the router name is given, that article will be retrieved, and all those sorts of nodes related to that question will be retrieved. But what else knowledge graph provides you is that, for example, there's a particular customer agent who's been working with that router and has been successful in debugging or improving, providing a solution for that problem. It can also retrieve his contact or search it out within the knowledge graph that this article has been used by this, has been contributed by this agent, and this is what was the solution, and it was highly rated or not. It provides the context along with that answer, not just the article related to that, right? And that context and the articles are passed on to LLMs, which kind of generate an answer. Okay, if you need more context, this is an agent, this who can help you with that, and this is the article that he has used to debug this problem, and that answer is provided back to the user. So this is the whole flow of a GraphRAG application, where there's a knowledge graph which is aiding the LLM in coming up with an answer as well as the context around that answer. So what is a graph retrieval pattern, right? So it's very simple, yet very powerful, right? Do a vector search, just like any other vector database, which you do with LLM, and find an initial set of nodes, right? That's where the vector RAG ends, right? It finds a node and it retrieves it. But in this case, you traverse the graph around those nodes and get the context for that, right? Which gives you a richer picture of what's actually happening or what might be related or what other people have done. All these sorts of things will be retrieved along with the article that you're interested in or a document that you're interested in. And then if it returns, 100,000, 20,000, or 1 million nodes, then you have an option to rank those results based on the particular relevance, context, time frame, whatever you decide on, which is provided by the graph, right? So it can rank those outcomes on a top K, outcome, and return that, which is very difficult to do with a vector implementation, where you kind of get a result. This is very much matching, but you don't really understand what's the context of this matching. Is it just a text-based matching? What else it is? But in this case, you get a richer context, and based on that context, you can write a customized ranking algorithm for those results based on the context that is returned to the graph. So what are the benefits of GraphRAG compared to a typical RAG implementation? Obviously, we have been working with it for some time, so we have our own experiences, but this is what the customers have been telling us. One is higher accuracy. GraphRAG is among adoption, one of the major reason is higher accuracy. So this is from Data World. This is a metadata management company, and they have published this benchmark that once they start using GraphRAG, and improve their accuracy by more than 3 times, right? You can scan this link, go to this paper, understand what they're trying to do, and it will help you understand, how did this improve accuracy. LinkedIn research, this is a paper that they have published. It's really very nice because it not just documents, their outcomes, that similar outcomes, like nearly 77% improvement in their accuracy, when they use GraphRAG instead of a normal RAG. But they also document, how they organize the data, their graph, their architecture, all that, and you can read about that, which is very interesting. And Microsoft has also, shared that GraphRAG not only helped them improve their accuracy, but some of the applications, some of the applications that they were, couldn't do with a normal RAG, they were able to implement that using a GraphRAG. And then obviously, one of the major reasons is easier development when using a GraphRAG. You kind of see that it can be visualized. It is easy to calculate the embeddings because it's in a graph. Within the database, you can calculate the embedding, and then you can visualize that result. Our AI engineer gave us feedback that just by visualizing those results, he was able to fix some problems which you can't do. So just to understand this a little better, for example, apple and oranges are both fruits. What will be representation in a graph world is an apple and an orange. They are both related to fruits, and it's easier to understand. But when you represent that in a vector DB, this is the representation that you get. So it doesn't really mean much unless and until you're some sort of a genius, which is even then it's very difficult to translate. Similarly, when you're talking about distance calculation between two nodes in a vector space, it's just like Euclidean distance or cosine similarity, which gives you a number. But really, what's the right number? It's very difficult to understand. But in similarity calculation in graph, you have lots of options. Node similarity, overlap, J-card, all these options come into play. And just to make sure you understand it, this is a vector representation, and this is a graph representation of the same data. It's so much easier to understand, and that's why just by looking at the data, you can fix some of the issues. And also in terms of explainability and governance for IT folks, you don't want everybody to have access to all the data, everything, which is very difficult to do in a typical RAG implementation. But in a GraphRAG, you can have a node level, access controls in place that a customer services representative cannot see what a doctor can see, right? So just these 3 benefits that we have listed here today. Then just going into a little bit more detail, like we'll go a little quick because we're running short of time. In terms of, graph representation, they can be, typically there are multiple types of graph, but basically 2 types of graph. One is a lexical or document graph where you have a document with this chunk into the chunks, and then those chunks are related to the document. And then you have a domain or entity graph where you have the actual entities related to each other, as we talked about in a service example. There are some documents, and then there are entities related to those documents. But obviously, these 2 types of graphs work together in a typical enterprise environment, which have certain types of documents as well as entities working together. So this is a sort of a knowledge graph that you can see in an enterprise. We have structured data, graph data, unstructured data, all related together and connected together. So just quickly going through the demo. So we won't be doing a demo, but I will give you the code and you can play with it in your own time. So for example, we are writing a chatbot for Eva who wants, so we are writing a sort of application for Eva who wants a neck top for her birthday. What can they do and how to solve that problem and how to match what's the right thing for her to do. The data is simple. It's a Kaggle H&M data based on search and retrieval, and then context of personalization, and then we recommend some tools that some products for her to purchase, right? And then on the basis of those products, we write an email, a personalized email using an LLM to be sent to the customer. If you scan this, you can get access to the Colab notebook. It's very cool, and you can play with it. Actually, you just need a sandbox instance on your Neo4j sandbox. Just connect it to your Colab notebook, and you can run through the notebook. I'll quickly give you an overview of what that notebook looks like. If you go in here, it gives you, the entire stack, the data, the code. You can just run through this code and, get an understanding of what we're trying to do. Sorry. Just a minute. It's good. So you can play with this demo in your own time, and it's very cool. So do check it out. Just to summarize the journey, you basically start with the typical data, you do the vector search, then you improve the result with some graph search, and then you use a graph data science and machine learning to improve recommendations further, and then you finally use an LLM to generate some content which can be forwarded to the user. These is a tool set, it uses LangChain, your account with Colab, and all those sorts of things. Then there's another demo, which is an LLM graph builder, which Angelo referred to initially. So you can scan this code, and you get access to LLM graph builder demo, which kind of is, gives you the access to generate a graph from unstructured data, and then actually connect it with your structured data. If you have one, you can do that, and then play around with it and get an understanding of how these two things work together. Basically, we're at the end of it. I'll just quickly show you the graph builder. What I've done is, I have kind of, ingested some YouTube links, some YouTube videos around recent ASX index that has happened due to DeepSeek, and then some results from the investment firms that have released the results. When you do that, you kind of get a graph around all these different entities, documents, and then what has been extracted out of it. And you can basically explore this graph when you visually see that, and you can analyze what is happening with different entities being mentioned over here, and then what's the relationship between these entities. So basically, it helps you, kind of get over that initial hurdle of getting a knowledge graph in place. Once you have a knowledge graph, there's a lot of things that you can do, and you can see that in the demo as well, where you have a recommendation engine running on top of knowledge graph. So that's it from my side. Any questions? You can, yeah.
The first lab you mentioned that up on your website, is it this one RAG retrieval augmented information then? You mentioned 2 labs.
Yeah. So you have.
Or new notes.
So this you have scanned this one. This is the second lab. This gives you access to LLM graph builder.neo4jlabs.com.
Yeah, because I didn't scan anything. I just wasn't using a lab.
Oh yeah, no. If you scan this is the URL. You can take a picture and then just go to this URL. This is the second demo, and this is the first demo. It gives you an example of a Gen AI workshop that you can do. So you can use this. Yeah.
Can you use the same concept to publish on your own LLM?
We are not tuning that. Yeah. Every day, right? In your knowledge graph, and your knowledge graph is augmenting the LLM. The knowledge graph building is separate topic compared to retuning or retraining the LLM, which is an expensive process. But knowledge graph is something which will not just aim the LLM, but the rest of your applications, fraud detection, all those sorts of use cases will be powered by a knowledge graph. And that just connected to LLM gives you a different dimension. But just retraining the LLM will not help you in the other things that you're doing.
I think you guys have a model on new page for your project for these other LLM implementations. Is that model built on top of like your knowledge, or is it there are examples where you can just work out with OpenAI or something like that?
So we are not in the space of LLM building, right? What we are trying to do is use that LLM to power something else, which kind of uses the knowledge graph at the back end, right? So LLM is not our domain. We are not retraining the LLM. We are using OpenAI and all those LLMs, but we are augmenting those LLMs with the knowledge graph, the organization knowledge graph, or whatever knowledge graph you have built in. So when you check out this application, the first demo, it basically shows you, kind of gives you a taste of how you can use LLMs and improve your knowledge graph or implementation.
Yes, just on this, like my exposure to GraphRAG is we have an application for Hugo on words. And essentially what it does is just goes through the knowledge graph, also on the
Yeah.
I mean, pass on the query to AI, and if you return back the cycle query. Right, and the cycle query that it takes on your knowledge graph and it back to LLM and then it comes back.
That's one of the patterns, right? That's one of the patterns where you're kind of using Cypher as a way to interact with the knowledge graph. But then you can use the knowledge graph to the LLMs to power content generation only, right? And use the data from your knowledge graph, right? So both of these things where structured and unstructured data are working together is a different concept. What you're talking about is text cipher conversion, right? Where you use a text, convert it to cipher, get the results back, and then give it back to the kind of AI or LLM. Yeah, you can scan the code, and that will also give you an idea of that notebook kind of goes through all these steps. Right, yeah. No.
Sorry to cover. That's very excellent speech for Angelo and research. So thanks to our first speakers, and you can just keep them ask for questions later. We have discussion session later. So let's welcome Hugo. He's gonna talk about LLM agents. I'll let him introduce himself first. Welcome.
Thanks, Hannah. Thank you for the great talk, guys. It was fantastic. My name's Hugo, and I'll introduce myself in a second, but just I'm here to talk about LLM agents, when to use them, and probably when to not use them as well, which will be most of the time, I think. And just a bit about me. I used to work in maths and biology and physics at UNSW, and then the Max Planck Institute for cell biology in Dresden, then Yale. Then I went to the dark side and went to industry, started working in data science, ML, AI education at Data Camp first, and very humbled to have had over 4 million students take my courses there, my Python courses there, in machine learning. And I worked in developer relations for a bunch of kind of Python stack companies and tools. At Coil and Out of Bounds, and now I've gone independent. I'm an independent data and AI scientist and consultant. I have a couple of podcasts if you like those things, Vanishing Gradients and High Signal. I also have a course that I teach 4 times a year on Maven.com called Building LLM Applications for Data Scientists and Software Engineers. But you didn't come to hear about me. We came to talk about agents, and just bear with me. I'm just getting over something, So first, it's worth defining what agents are, I think. So first we'll talk about what agents are, then talk about on the continuum leading towards agents. What is a more useful term, I think? Augmented LLMs. So LLMs that can use tools, right? Like search the web or calculators and that type of stuff, and typical workflows we see there. Then I'll get into kind of the nitty-gritty of some multi-agent architectures, and finally, to deliver on the promise of being here, talk about when to use agents and when to not. So I'm sure everyone's just been overwhelmed the past few weeks as it comes in ways where we've seen DeepSeek in the past month or so, then deep research from OpenAI, Claude 3.7, Replit agents, all of these things. This is, I could have picked 20 other ones, but something that happened was DeepSeek kind of came out and had these interesting search capabilities that there was a fast follow by Perplexity as well, actually, with their deep research. So we had OpenAI deep research, Perplexity, and so on. So we already see these type of mini intern research capabilities being commoditized in a matter of weeks. So things are moving very quickly, and they're all kind of agentic in some way. And we actually saw, just want to show you what Ethan Mollick tweeted out yesterday. It was what he did with Claude 3.7 to create a JavaScript code that would generate this. And tried this with many different LLMs, but this is one. He wants one that will startle me with its cleverness in creating something that invokes the control panel of a starship in the distant future. Claude 3.7 gave him this. About a week ago, Grok 3 gave him that. So the point is that we're having these things that are they are LLMs in a lot of ways, but they're building things and doing things. And my so I'm not taking a call. There's no internet here, so I need to tether in order to do this. And
created code, like use it, leverage an LLM to generate application.
yeah,
Start to end to see that.
it's fascinating stuff, isn't it? So
Is security.
we know that LLMs can generate text, but what other things can they do? Can they actually take action in some sense in an environment, right? So can they automate workflows? Can they interact with external systems such as databases and APIs? Can they perform calculations? So what exactly am I talking about? I'm talking about information retrieval from GraphRAG, for example, right? Can they access external sources like databases, APIs, or knowledge bases to fetch specific data? Can they run code? Can they execute scripts or calculations in environments like Python to solve problems or process data? So I think one of the big jokes about LLMs is that they're horrible calculators, right? And people say we shouldn't expect them to be calculators, but they're software, so we kind of do. I mean, ChatGPT famously is horrible at calculating the number of R's in the word strawberry, right? So can someone tell me, if you wanted to get an LLM to calculate 2 + 2, how would you do that? Does anyone have an idea?
Like in Azure, I know how one option is that you can use an LLM to get the input, and then they have the capability to connect with another thing. Like you can connect it with Python, say, for example, and you push that to Python.
Yeah, let me just repeat what you said. You're getting it to push the computation to Python. Okay, so it has to write. Does the LLM write the Python code?
No. So it can, like in Azure, they have this option.
No. I'm not asking. I'm sorry. I'm not asking about Azure. I'm asking about if I'm doing this on my laptop with. How would I'm just working with an LLM. How would I get it to perform a calculation?
In that case, if you try to search in its memory, it has to do it. So that's my guess.
Okay, so that's one approach which won't work a lot of the time. Does anyone else have? What's that? Right, so if I want to automate it using an LLM, how would I do that?
Just like
What's that?
run to ChatGPT to
If for more complex calculations?
Claude does it.
you define a function, a Python function, and you apply that as a tool to the LLM, and then
Exactly.
it just generate that.
So you can get LLMs to generate code for you, and then you can get it to execute code, right? But there's a huge problem with that as well, because the suggestion there is for it to generate code, I have to believe that it's going to generate the correct code. And am I going to allow any arbitrary Python code to run on my laptop, right? So the answer is no to that. Suddenly I need to, that's why Claude Computer used it, like, let's Dockerize everything and, be very, very careful, right? So there are extreme challenges that come into play already when we're starting to do even these simple things. So we really need to specify what environment we allow it to work in. Of course, the other solution, which I like far more, is get an LLM to generate the code, and then I look at it, right? And then decide. And similarly, if I'm getting it to read and write from a database or my local file system, maybe it can tell me what it's reading from, what it's writing from. I verify it and allow it. Have a human in the loop in a clever way, right? So we also want them to handle multi-step tasks, so to break down complex problems. Let's say I want a 10-bullet summary of the latest and greatest AI tools, right? It would need to search the internet and then put that into 10 bullet points. So it would break it down into those steps. Perhaps there are different LLMs in that sequence. One will do the search, and then one will break it down. So we have a researcher, and then perhaps one that compiles the knowledge into bullet points. The other thing, we have all these terms around like make decisions and choose, dynamically choose. I prefer to think of it as triggering actions. I'm not necessarily comfortable with saying LLMs are making decisions, but we want them to activate appropriate strategies, tools, or next steps based on context and inputs, right? So this is moving towards agents. And I do want to say that, pardon me, ChatGPT, for example, many of you may know this, but it already does somewhat agentic stuff. So is that, yeah, I'm going to say, hey, ChatGPT, you're an expert marketer, and I'm down at the Docklands, and this place is a rebrand. So could you give me a new marketing campaign for the Docklands in Melbourne, and give me some images to go with it? Also search to see online to see what Docklands is before doing this. I have no idea what it's actually going to do now. The demo gods are spiteful and vengeful, so you'll see. Okay, great. So it's found me some either real or fake images of the Docklands. It looks kind of real. Campaign theme, Discover Docklands, Melbourne's waterfront playground. Melbourne's attempt at Darling Harbour. So I'm from Sydney, so that was just a little jab. Because I think Melbourne's a better city, by the way. I'm one of the few people who just, I grew up at the beach, so it's impossible to live here. The point, I don't even care what this marketing campaign, oh, and look, sunset over Victoria Harbour, Melbourne Star, observation wheel at night, because of my internet connection, it's going to make me, anyway, the point remains that ChatGPT did something kind of agentic already, right? It searched the internet and then gave me a bunch of stuff and synthesized it in the way that I asked, okay? So this all begs the question that I started this section off with, what is an agent? And it isn't something that's really well defined at the moment, but I think we've made some pretty good steps towards it. And these are from some blog posts that I'll share in the resources at the end, and I'll share my slides. From a Hugging Face blog post, and I'd highly recommend the Hugging Face course on agents that just came out. AI agents are programs where LLM outputs control the workflow, okay? So I won't necessarily say, I didn't tell ChatGPT to use Google or to use Bing or whatever. It figured out which one to use based on my directions and its own weights and moved from there. Anthropic have also talked about it, and we're going to go through some of these workflows in this talk. I love the idea of thinking about workflows before agents. Workflows are systems where LLMs and tools are orchestrated through predefined code paths, right? So you have one LLM doing something, then another one doing something else, and so on. This type of modularity is actually incredibly important for good software design, among other things. Agents, on the other hand, are systems where LLMs dynamically direct their own processes. So once again, that ChatGPT example, I didn't tell it which tool to use. It dynamically figured it out. And then my friend Eugene Yan, who I think he's at the AI Engineering Summit in New York at the moment, he's at Amazon working on recommender systems and LLMs there. Once again, he's just retweeted Anthropic talking about how an agent is essentially a model plus tools. With some sort of control flow, so a for loop or a while loop, and some environment it operates in, such as the internet, for example, or my local file system. So now I want to jump into thinking about these augmented LLMs, and typically